Great. Thank you so much. So first of all, we start with the Sharp's coefficient for this question. We start with the Sharp's coefficient for this question. So Sharp's coefficient, what do we have here? So remember, this is the question that wants us to look at to rank using Sharp's method. Most important is us to remember that under Sharp's method, that Sharp's coefficient itself measures a premium of any security per unit of total what year? Per unit of total risk, isn't it? And how do we calculate this premium? It will be returns of the security minus risk-free all over total risky standard deviation. Total risky standard deviation, yes. Total risky standard deviation. So then we shall be able to calculate for all these securities. The first one being a P. This is May 2017, remember. So the first one is security P. So security P, are we able to see the average returns of P? Oh, yes. There are 18.0 here, somebody? Are you able to see the risk-free rate? It's given down there, 9, isn't it? Divide this by the standard deviation of P. 27. So this one here gave you what figure? 0.355. Another 5. From there, we go to the beautiful Q. So Q, I can see the average return there is 14.6. Risk-free does not change. Standard deviation of Q, I will be able to read there, which is 18. So this one I gave you guys what figure? 0.322. Another 2. Beautiful Q. From there, we go to R. So R, I can see the average return of R is 15.1. Yeah, minus 9. All over the standard deviation there, which is what here? 8. Which ended up giving you guys what figure? 0.7625. Thank you very much. From there, we went right away to, after R, we have our famous there, S. So S, I'm able to see the return of S. The return of S, ladies and gentlemen, is 22, eh? Yeah, minus risk-free, which is what? 9 to get the premium, divided by the standard deviation of S, which is 21.2, you're right. Which then ended up giving you guys what figure? 0.613. After S, ladies and gentlemen, we go straight away to T. So T, I will take the average return of T, which is negative 9. Minus 9, isn't it? All over the standard deviation of S, which is T, which is 4, right? 4. Which ended up giving you guys what figure? Negative 4.5. Thank you so much. After T, I can see U. So what is the average return of U? Minus 9. All over the standard deviation of U, which is 19.3, eh? Yeah. So which ended up giving you guys what figure? 0.9067. Thank you very much. And that is all the 6 securities. Don't evaluate the market. Don't evaluate the market. So then go ahead and rank them. The examiner wanted us to rank them. So which one takes number 1? 0.90, right? So this takes number 1. After that, the next one is 0.7. So this takes number 2. And then 0.6, eh? Number 3, number 4, 0.35. So this takes number 5. And then the last one is the negative one, isn't it? 6, like that. That one, you guys were able to get this pretty fast. And I can see there are so many comments here. 18 new comments like that. So the moment you have circled like that, you've been able to rank them like that, you get all the marks. So can I go to the trainers? The trainers, I hope this is okay and I can rub now, eh? Yeah. So the trainers, they are very important formulas that I must be able to show you here, which you should be able to really master. You must be able to master this. Now, so number 2, the trainers. The trainers, yeah, model. So again, this gives premium per unit of systematic risk. Systematic risk per unit of systematic risk, i.e., it is premium over beta, because you see, systematic risk is measured using what here? Beta. So anytime they want us to give them the trainer's coefficient, we shall take the returns of the security. We say minus what here, somebody? Risk-free. But now we come and divide this by beta of the security like that. But now in this question, the examiner never gave us beta. This beta, now I'm using this opportunity to teach you like how do we calculate this beta, which is a measure of what is systematic risk. How do we get this beta? It's very, very easy. So anytime they want us to give them beta, ladies and gentlemen, we must always remember that beta between beta of a security, I will always take the covariance between the security and the market, all over standard deviation of the market squared. This is so important for you. Yeah. This is so important for you. If they want us to give them beta of a security, we shall always take covariance over S and M divided by the standard deviation of the market squared. But we also have in this case here something that we call correlation coefficient. Correlation coefficient. Correlation coefficient. So please listen. If they want us to give them the correlation between S and M, yeah, we shall take covariance between SM divided by standard deviation of S, standard deviation of M. So please write like that. So if they want us to give them correlation, it will be abbreviating like this, SM. It will be covariance SM divided by standard division of S, standard division of M, like that. Is that okay? Now, I want you to make covariance the subject of the formula. Make covariance SM the subject. So if you make covariance SM the subject, this will be covariance SM equals RSM, standard deviation S, standard deviation M. R stands for correlation coefficient. Write your normal R. Write your normal R. Then I would want you to do me a favor. Come and give me beta in terms of correlation. Yeah, give me beta in terms of correlation. So then this beta of S, instead of writing covariance, please write this. RSM, standard deviation S, standard deviation M, over standard deviation M squared. So beta S will be equal to RSM, standard deviation S, standard deviation M, standard deviation M times standard deviation M. Because you see standard deviation M squared is standard deviation M multiplied by standard deviation M. So what am I seeing, ladies and gentlemen, here? That these standard deviations M, see, I can do what? You can cancel. Those two can cancel there. So we are learning two important formulas of getting better. Very important formulas of getting better that you shall always remember Always, you as a finance scholar, there are formulas that you must always remember. Who will ask you to derive, eh? Nobody will ever ask you to derive this. I'm only deriving this for you to be able to see, but you will be required to cram this. You'll be required to cram this. That number one, yeah, this is very important note, that to get beta of a security, you'll be taking covariance between SM divided by the standard deviation of the market square. We call this one the covariance approach of getting beta. Covariance approach. This is number one. Number two, you can also use what we call correlation. You take the correlation given, you multiply this by the standard deviation of the security all over the standard deviation of the market. This is how students like it. This one here. You take the correlation provided, and then you multiply them with this quotient. You multiply them with this standard deviation of S, all over standard deviation of what here? The market, like that. The moment you master this that way, you'll always be correct in these questions. So I would want you guys to do me a favor. We get beta first of all for each of those 6 securities. So I would want to give you exactly 3 minutes to see whether, because they have given us correlation in the question. This question, they have given us correlation, meaning that you're going to use correlation approach to get the betas. So I want us to get these betas, ladies and gentlemen, using this correlation approach. So how will this look like? So we have here, so here we shall use correlation approach. To calculate beta. Yeah, because they've given us correlations. And if that is the case, then to get beta of the security, I'm taking the correlation provided and standard deviation of the security over the standard deviation of the market, ignoring the percentages. So we start with P. Is there somebody who is able to see the correlation of P? Is there somebody who is able to see the correlation of P? Please talk to me. I'm not the one who is bad. You guys, of course, before you came here, examine alijua mmeiva. Si ni ukweli? All of you are qualified to be here. You are here legally. So the correlation of P is 0.81. Are you able to see the standard deviation of security P? What is the standard deviation of security P? 27, isn't it? 27. So is there somebody who is able to see the standard deviation of the market? It's given down there. 12, right? It's given down there because you can see the market return. And the market return, we have an average return of the market as 12, but beneath there, besides there, we also have standard deviation of that market, which is 12. So I can point it for the online students. You can see it is here. Standard deviation of the market is 12. Have you seen it? Have you seen it, all of you? So these ninjas are giving us an answer here. They're telling us that the beta for E equals who? Marvin, my friend, 1.8225. Is that okay? 8225. I repeat, why 12? It's because you see standard deviation of the market. The examiner never wanted to give it to you directly. They only gave it to us here. Market return. This is the standard deviation of the market. Here, down here. You can see standard deviation of the market security is 12, given here. Besides the market security. I hope that is good enough. So they're giving me an answer of 1.8225. Go to the next one. The next one, ladies and gentlemen, is Q. So Q, is there somebody who can do Q for me without my intervention? So without my intervention, I can see the correlation of Q, which is 0. What here, somebody 6? 0.65, right? Times, in this case, standard deviation of Q. Standard deviation of Q, I can see it is here. It is given as 18, isn't it? Divided by standard deviation of M. Standard deviation of M, ladies and gentlemen, it is known and will remain constant throughout, which is 12, isn't it? 12. So what figure are we able to see there, my good students? Yeah, 0.97. 0.975. And please don't let me down when they bring these kind of questions in your exam. Don't let me down. You should be able to really excel here. You should be able to excel here. Now, ladies and gentlemen, after that, then I will be able to go to QS. Now, I'll not to do all the donkey work. I expect you guys now to give me all the answers now, because now you are so good, right? Now you are so good. Now you can give me the 1 over R. I just want to copy down your answers there. And of course, then if you're not able to get it, now I can comfortably dive in as a CPA Chief Ninja. So for R, I'm being given 0.6533. 0.6533. R, 0.6533. How about S? How about S? Thanks, Marvin. Thanks, A1GCO. Lincoln is giving me 1.3250. 1.3250. Is that okay? Great. Thank you so much. So I'm waiting to be given the others like T and U. T and U. And then I have a new ninja here called 𝑚𝒂𝒃𝒃, who is also very good. Lincoln has already gotten for T. They are telling me that, Mwalimu, don't even waste your time writing those many things, because T is 0.15. I don't know whether the online, not online, but physical students here, are they able to concur with that number? And then U, Kelby, my very active student as well, is giving me U over 1.00133. 1.0133. Is that okay? Yeah. So are we finished doing the question? No, we were simply getting beta. After getting beta, now we should be able to get what we call the trainer's coefficient, of which the formula now you have. So the trainer's coefficient, ladies and gentlemen, we know it is returns of the security minus risk-free divided by beta of the security. R, Maslin got R of minus 0.585 R, eh? R, Maslin. Yeah, 20 marks question, yes. Of course, there's a theory down there. So Maslin got R of, let's see how she got R of negative, eh? How? So remember, it is correlation, Maslin, times standard deviation over S over standard deviation of the market. So for R, are you able to see the correlation for R? Please help me out. R, the correlation is 0. For R, please help me. 0.98. Ubano mkishajua sama naniacha. 0.98, eh? How about the standard deviation of that security, R? Are you able to see it is 8? 8. Divided by 12, Maslin. How could you get even a negative number, Maslin? We shall overcome. We shall overcome. We shall overcome. I hope now you are okay, Maslin, with how we got that 0.6533. Now we are getting the TCs, the trainers coefficients. Now we are getting the trainers coefficients. So then I would want you to give me for P, are you able to see the returns of P, the average returns of P? 30 what? Average returns of P? 28. 18.6. How about risk-free? 9, eh? How about beta for P? 1.8225. So please now get for all the others. Thanks, 𝑚𝒂𝒃𝒃. Great. Now I want you to get for every security. And then you post your answers here. And I'm giving you exactly 5 minutes. 5 minutes. All of us should be very good at that. Great. So we continue. So in this case here, we have been able, I hope you guys were able to get those trainers coefficients. Do we have them? Do we have all of them? Yeah, so we have P. Have you been able to rank? Yeah, so if you've been able to rank, now we can go to part. Is there any figure you are not able to get, which you would want Mwalimu to do? Any figure, the online students, any figure that you want us to calculate? Now, of course, you bear witness with us that the two methods are not ranking those securities in the same way. Or are those rankings the same? No, the way 𝗏s is ranking is not the same as the way this trainers is ranking, isn't it? And then part 2 of that question, part 2 or part 3, they have asked us to give them 2 reasons for ranking differences. Why are we having differences in ranks? Can somebody give me a reason? I don't expect them to rank those particular projects in the same way. Simply because, number 1, the basis of measuring risk is different. Yeah, so number 1, the basis of risk measurement is different. The basis of risk measurement is different. It's different. Give us a dash there that 𝗏s ratio uses what? They are forgotten. 𝗏s ratio uses standard deviation. 𝗏s ratio uses standard deviation. And then trainer's ratio uses what here? Beta. So, I mean, if the bases are different, we expect different numbers, isn't it? We expect different rankings. And then number 2, which brings in this case here ranking difference, is what we call diversification effect. Diversification effect. Diversification effect. Tell us that portfolios that are well diversified, show similar 𝗏 and trainer rankings. Portfolios that are well diversified or perfectly diversified, they show similar 𝗏s and trainers rankings. Another dash. Portfolios that are poorly diversified, they show different rankings. So basically, whenever they ask about differences in terms of how the two methods are ranking these particular projects, always remember the concept of differences because of what are the basis of a measurement of risk. And then number 2, what we call diversification, what your effect. That way you are okay. Now, with your permission, ladies and gentlemen, I'll be able to go straight away. Have you written something to do with the diversification effect? Okay. So under diversification effect, what have they written? Let me just repeat. It's important. So the diversification effect, portfolios that are well diversified show similar 𝗏s and the trainers rankings. So if they are well diversified, yeah, and then portfolios that are poorly diversified, they show different rankings. So of course it means that our portfolios from P to U were not very well diversified. They weren't well diversified. They were poorly diversified. That is why the rankings between the two models are different. Thanks. All right. So then with your permission, I'll be able to go to our last area today, before you go to sleep, right? Yeah. So I would want us to look at this question that they keep on repeating. Yeah. What is beta coefficient? Somebody wants us to tell them what beta coefficient is. Remember what we said in our last week's class. Beta or beta is a measure of what is systematic risk. It's a measure of systematic risk. Just like how we have standard deviation, which measures total risk, then beta measures systematic risk. That risk that cannot be diversified. That risk that cannot be diversified. That risk that can't be diversified. Now, the title there, give me a title there, optimal proportions. Optimal proportions. Optimal proportions. And we're using this question that I'm sharing here on the screen, May 2014, question number 1. If you have that handout on the very last page, we have May 2014, question number 1. The very last page on that handout that you guys have as well received here. Optimal proportions. Optimal proportions. Optimal proportions. Optimal proportions. Optimal proportions. Very, very popular. Very popular. Very popular. So optimal proportions, ladies and gentlemen. What do we have there? May 2014, question number 1. May 2014. May 2014, question number 1. From that handout that I've just sent, the very last question on that handout, last page, the last page, then I'll be able to define what these optimal proportions are. May 2014, question number 1. May 2014, question number 1. May 2014, question number 1. If they've gotten that question, I would want us first of all to read it. So a fund is split between two securities, X and Y. The following data relates to these securities. We have variance for asset Y. So this has been given. Variance for Y. It is 297.6. 297.6. Then we have in this case here covariance between X and Y. Covariance between X and Y, it is minus 54. And then we have, ladies and gentlemen, the variance for X. Variance is standard deviation squared. So the variance for X, ladies and gentlemen, we have here 10. 10. So we are required to provide the proportion that an extremely risk-averse individual would place in a portfolio comprising assets X and Y to obtain a minimum standard deviation. So once they copy whatever I have here, can they simply say there Y for yes, and then we continue. Then we get to continue. Finished? Oh, Y for yes, okay. Lincoln, some appear Y for yes. Fine, Y for yes. So these optimal proportions are also known as optimal weights. Your examiner will ask you for optimal weights. So if you want to get, first of all, before I tell you what optimal proportions are, if they want us to give them weight of X, this is what we shall always do to get weight of X. Very, very important, the proportion of X. So I will start with the variance of Y. Yeah, if I want to get weight of X, I say variance of Y minus covariance of XY all over variance of X plus variance of Y, yeah, minus twice covariance XY. This is really important. This topic has got so many formulas. But if you keep on repeating whatever I give you in a class, you'll always like the paper. But of course, if you're a person of so many excuses that I'm busy, you're busy, no. Just create time, go through, just keep on reading what I give you and you'll overcome. So anytime they want us to give them weight of X, we shall always in the numerator start with a standard deviation of Y squared. So like in this question, if I try to plug in, are you able to see the variance? You see this variance of Y? I can see it is here, 297.6, right? Minus covariance XY. So covariance XY itself is minus what here, somebody? Is minus 54. covariance XY is minus 54. Yeah. So then come here and give me the variance of X I can see it here. It is 10 plus the variance of Y. I can see variance of Y there. It is 297.6 minus twice covariance 54, which is minus 54 like that. So can you kindly do me a favor? Please give me the numerator answer. So you say 297.6 minus 54. You give me a number I write. You give me a number I write. 297.6 minus 54. Give me a number I write. I will be so happy. So according to Archer, it is 351.6. Divided by, how about the denominator? Denominator, it will be 10 plus 297.6 minus 2 times, because brackets means times. So times, open brackets, minus 54. Minus 54. So you give me the denominator slowly. Denominator will end up giving us what answer? So according to Marion, she's getting 415 point what here, somebody? 0.6 like that. So then are you able to give us this answer? Are you able to give us this answer? 351.6 divided by 415.6. That gives us what figure? 0.846. Thank you so much. So if you've gotten, in this case here, the weight of X as 0.846, what do you think will be the weight of Y? The two must always add up to 1. The two must always add up to 1. So to get weight of Y, I will take 1 minus 0.846, which will end up giving us what figure? 0.154. 0.154, like that. Please listen. I would want to make myself clear as I disappear. As I disappear, I would want to make myself very, very clear. And you shall never forget this, my good students. Please listen. Please listen. So here, we have here, if for example, somebody was to ask me, use the formula to get weight of Y. How will I be able to get this weight of Y? So this is method 2. Method 2. So to get weight of Y, just know that you are starting with variance, eh? But now this, you know, the interchange. Now this time around, we shall talk of variance of what here? X. The moment you appreciate that, if it's Y you want, you start with the opposite variance, and then you say minus covariance XY all over variance of X plus variance of Y minus, because there are 2 of them. So now we say minus 2 covariance XY. So then WY will be equal to, please listen, are you able to see variance of X? It's given. It is 10, isn't it? Minus covariance of XY. And that covariance happens to be a negative 50 what? 54. All over variance of X. Variance of X, already we have it. It is 10 plus variance of Y. Variance of Y, which is 297.6 minus twice covariance over, I can even say times here instead of brackets, eh? So times negative 54. So please give me the numerator. Please give me the numerator here, 64. How about the denominator? How about the denominator? The same, eh? I've rubbed mine. Are you able to get 415.6? 415.6. So are you able to give me this weight of Y? Is it the same as 0.154? It is the same as 0.14. Are you able to see some similarity with something? Are they able to see some similarity with something? Yeah, because we are done here using the other method, we got WY as 0.154 like that. So those 2 formulas, you shall never forget them. So see you tomorrow in our advanced financing decision Bye. Okay. Is there a session today at 10 p.m.? No, 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 no. That will be too much. I will tell you when I will start at 10 p.m. I'm not ready today for the 10 p.m. Tell your friends like that. Thank you. Appraisal ratio. Remember what we said with appraisal ratio? What do we do? Are you able to remember how to get the alpha value? Alpha value. Because if you're able to remember the alpha value, you take the alpha value divided by the non-systematic what here? Risk. You take the alpha value where you take, in this case, the expected return over a security minus CAPM returns. Yeah. If you're able to get this, then that is it. Unfortunately, I have a class starting at 8. We shall overcome. All right. So the online guys, I hope with all the problems, you guys are enjoying the sessions. You're finding the sessions to be valuable.